We will now look at some relationship examples in Tableau. These examples are sourced from higher education, the focus of this Tableau user group. This presentation was originally part of the Canadian Higher Education Tableau user group in October of 2020. It was based on Tableau version 2020.3. The examples that we'll walk through are actuals versus targets, the subject of this video. The second and third examples, students and learning management systems interactions, and data densification, are the subject of future videos. So, our first example is graduate outcomes versus government targets. Imagine that the government decided to set targets for the number of students completing credentials who say that work-integrated learning helped them find a job after graduation. In this context, work-integrated learning, or WIL, is the opportunity for a student to engage with industry or an employer in some capacity. The most common forms of this are cooperative education work terms and internships, but there are others. The end goal is to create a D&E chart, similar to the one that you see on the right. In this context, the blue circle is the government target, while the orange circle is the number of students who said that work-integrated learning helped them find a job after graduation. If the orange circle is to the left of the blue circle, this means that the province shown is under target, such as we see with Alberta in the first row. Conversely, if the orange circle is to the right of the blue circle, this means that the province is over the target, such as we see with British Columbia. These targets are imaginary, so no province is inherently under or over, but bear with me for the example. The data shown here is based on the National Graduate Survey conducted by Statistics Canada. We've adapted it in a number of different ways. In particular, we've excluded the national data in favor of provincial level data. Additionally, we've made some modifications to how the data is presented, such as pivoting and so on. Creating the dataset will be the subject of another video. We created the dataset using Tableau Prep Builder. The basics here are that we connected to the National Graduate Survey data as downloaded. We then made some cleanups to it. We did some conversions, we renamed some fields, we joined them back together again. We did some pivoting and brought it all back together again. Ultimately, this resulted in a dataset called grads being output at the record level relative to this dataset. Additionally, we output one more dataset called targets. These targets, as mentioned previously, are fake. We used two different methods to create the fake targets. One was NumPy using the Python integration. This was the more accurate of the two for our purposes. We also used the random function built into Tableau, which is unsupported and produces sometimes erroneous results. Part of our example here was to compare the results that these two different methods output. Ultimately, both examples were written to a hyperfile. However, we also could have published them to Tableau server, written them to a database, or created CSV files, depending on our needs. So let's go to Tableau Desktop and see how this looks. For our first example, we're going to start with Tableau version 2019.4, which was released before the new data model. The purpose here is to show a couple examples of where the old data model can be limiting. So first off, let's connect to our data. The two files that we have are the National Graduate Survey as a hyperfile and the NGS Government Targets also as a hyperfile. So for this purpose, National Graduate Survey is our actuals. We'll drag this onto Tableau first, and then we'll drag the NGS Government Targets on second. When we drag this onto Tableau, we have the opportunity to rename the table. To keep this a little bit cleaner, we're going to do this first. I'm going to call this survey-actuals. And then I'm going to drag government targets on. I'm going to call this one targets. In turn, we need to join our data together. Tableau guessed at DGUID, which was pretty good. We're also going to join it on Geo, just to be on the safe side. At the province level, it doesn't matter too much. However, at more granular level of Statistics Canada data, there are occasionally places that exist in multiple provinces, such as Lloydminster, on the border of Alberta and Saskatchewan. In addition to the geography, we want to join this based on field of study because that's what's in our data. Okay, The next thing that we're going to do is we're going to click on the Help menu and we're going to turn on Performance Recording. This will help us see what's happening a little bit underneath the covers. So let's have a look at what we have. As expected, Tableau has organized our data based on the dimensions and measures, and within those, the specific tables from which those fields reside. We're going to make a simple bar chart as a start just to illustrate what's happening here. So let's imagine that I only actually care about the actuals for now. Let's say that we're going to look at the number of students who said that we'll help them find a job after graduation. So let's have a look at that first. We're just going to make a simple bar chart by province. I'm going to double click on Will, and I'm going to turn on labels just to make it a little easier to see, and then I'll double click on Geo. Okay, so now I can see that, for example, Ontario had 108,000 students that responded to this survey who said that work-integrated learning helped them get a job after graduation. For the starting part of our example, the reason we turned on Performance Recording was to show what query was generated by Tableau for this purpose. So we're now going to turn that Performance Recording off, and a new workbook will open. We'll make sure that our slider is all the way to the left, and then we're going to try and find where we executed the query. This is in green. So now that we've found our first query, let's take a look at what it's doing. It's a little bit squished on Tableau here, so we can increase the size by messing up our dashboards a little bit. And we can make it fit. This may not be the case for all of them, so you may want to right-click on the result and say View Data and copy it into a text editor or SQL editor or similar. But for our purposes, we can keep the query here because the point is fairly simple. So we can now see the underlying query that Tableau has generated to our data based on the bar chart that we had. What we can see in the outer part of the query is that we're comparing Geo to the sum of the number of students who said that we'll help them find a job after graduation. Tableau's done some footwork around an inner query as a starting point, and so this particular one looks at our actuals, which we can see here. In turn, Tableau has renamed this as T0 or Table 0. It is then joined to our targets table based on the conditions that we created when we first created this data source. And it's being grouped by the first field in our query, which is geography. So select the sum of the number of students who said we'll help them find a job after graduation, grouped by geography. Now, we bring this up because we didn't use targets for anything, but using a physical join like this means that we have to join together our two tables in order to see the result. So let's compare this to Tableau's new data model coming right up. But before we get there, just a couple other points on physical joins. We hadn't brought in our targets yet, so let's do that as a starting point. Look at the government target field. Let's just double click that, and we'll make it a dual axis, and we can make them Gantt bars, just for sake of argument. We can see here that for the only province where our fake targets are different enough, that we've got an order of magnitude difference. This is a bit problematic. So if we synchronize the axis, this effect is a little bit more transparent. So what we can see here with Ontario, for example, is that we're targeting 1.2 million, but the actuals are 108,000. So why might that be? Well, the answer is a little bit simpler to see in a crosstab. So let's right-click this and duplicate it as a crosstab, and then go to that new sheet. So now we have this huge amount of targets based on the province. I'm going to double-click on Alberta just to simplify this so we can see one at a time. It's a little bit easier. Remember how we said that this was based on field of study. And then let's move our measure names up to columns just so we can compare them a little bit more easily. So now we can see this factor of 10 thing happening for all the rows pretty much that we have data, give or take a little. We can also see that we have targets for rows that don't have any data whatsoever. In turn, what's happening here is that our targets are being duplicated for all the rows in our actual data. So if we add the additional information like level of study, we start to see the pattern here. For example, bachelor's through doctorate and everything in between has a target of 3,157 within the field of study of agriculture and natural resources and conservation in Alberta. When we add all these numbers together, we get that obscene target. So a conventional join will duplicate our targets because it's going to add a target for every single row in our actual data. You can imagine the compounding effect that would happen here if we actually had student level data rather than aggregate level data for our search. If you remember only two things from this example using the old data model, it should be that thing number one is that targets and actuals are difficult to compare using a conventional join. In this example, we have field of study, level of study, and sex, as well as geography, such as province, for Alberta in this case, as part of our primary data in the actuals file. We're comparing it to targets that are much more aggregate, that are based only on field of study and geography. So what we can see is that for every level and every sex in the data set, our targets are duplicated. This results when we roll up our data to a higher level in exceptionally high targets relative to our actuals. This is a bit problematic. The second thing that matters in terms of the new data model is that in the old data model, Tableau will query both underlying tables, even if we've only used one of them, such as before we brought the government targets onto our view here. This is less efficient from a database perspective. You want to ideally query from. There's one other way that we could deal with this problem using the old data model. This is known as data blending. To do this, we want to start with our graduate survey as our primary data source. In this case, we're not going to join it. Let's make a new worksheet. We'll call this one blend. We're not going to join it. Instead, we're going to blend it. Then we'll drag our second data source, our targets, onto Tableau as well. We can now see that we have two new data connections up here in our data pane. To do a data blend correctly, we need to put some information onto our view. So let's double click on Geo and we'll double click on the number of jobs after graduation. From here, we can then click on our targets and we can add our government target. Our comparison here gets slightly more realistic. If we choose to add our totals, we can see now that we're not an order of magnitude different. There's still some nuance here that we've got to clean up, but we're pretty close. So what we can also do is we can link it based on the field of study, which is not on the view. Now, if we put field of study onto our view, we can see that, well, there's some differences in terms of the overall targets. It's a lot closer than the joining method, so this could be considered accurate for our purposes. The challenge here is if we forget to link a particular field, such as province, we can see how our government target, the first column, changes. Blends are based on a particular worksheet. And as a consequence, if we make a mistake on one worksheet, it may compound on us, or we might need different blending on different worksheets. So there's advantages to blending, but this probably isn't one of them. We'll now open the same data using the new version of Tableau. This is version 2020.3. As we did before, we're going to drag our files onto Tableau, only this time it's going to look a little bit different. So what we can see here is that our table is still called extract, but this is the new data connection canvas. We're going to rename this as we did before. We'll call this survey actuals. We'll then go back and connect to our targets as well. Rather than automatically creating a join, what we can do instead is click on our government targets extract and drag it onto the canvas. What you'll notice now is a curved orange line that Tableau affectionately calls the noodle. This represents relationships between the two tables. We can think of this as a contract between our two tables that specify when we pull data from each of them how it should relate to each other. First, it's going to ask us about the relationship. So let's set it up the same as we did with a join. We're going to base it on DGUID for completeness. Then we'll hit close and add another field for geo. We'll hit close again, and we'll add one more field for the field of study. And then we'll hit close. Last but not least, I'm going to rename this. I'm going to call this targets. These are what Tableau calls logical tables. They live a layer above the physical tables, as you saw in the previous presentation. If you want to edit what lives in the physical layer, you can either double-click or hit the drop-down and say Open. Here we can see that Survey Actuals consists of a single physical table that exists in our data. In my case, it's called Extract. But it could be many tables if we needed to. Targets is the same story, so if I double-click on that, I can see that it's made of Extract 1. And then we have this relationship between the two. So now I'm going to turn on performance recording again. And I'm going to say start performance recording. I'm going to go to worksheet number 1. And I'm now going to look at the number of students who said that Will helped them with a job after graduation. I'm going to make a bar chart just like I did before. Note that there's subtle nuanced differences between how Tableau in the newer versions with the new data model lays out our dimensions and our measures. Now, within each logical table, I have a set of dimensions and a set of measures. Outside of the logical tables, I have fields that are global, like measure names and measure values. Additionally, any calculations that I make that rely on fields that exist across multiple logical tables, such as comparing actuals to targets, these would appear here as well. So, our first step is let's make that simple bar chart as we did before. I'll double-click on the number of jobs after graduation, and I'm going to turn on the labels. I can see it's 135,000 or so. I'm then going to bring in geo. I can now see that Ontario has 54,000 odd. That's good enough for now, so let's turn off our performance recording and see what it looks like. I'm now going to drag the slider to 0 seconds because my query is actually pretty quick on this very small data set. I'm then going to scroll down until I find something that looks green and see if it's the one that I'm looking for. This looks pretty good. Okay, so our second query, basically, that we ran once we added province to our view is much simpler than in the previous version of Tableau. Here we can see that we're selecting the field extract and the sum of the number of jobs after graduation. Of important note here, we're selecting it only from the table that's named extract, which in our case is our survey actuals, and we're grouping it by the first field, which is geography. So the important part to note here is that we're querying only one table, because that's the only table that we need to answer our question for how many students said this on the survey. We are not querying the targets because we haven't used them for anything. If I compare this to the query that we ran in the old version of Tableau, where we had an inner join to the targets even though we were doing nothing with them, the new version is substantially more efficient from a database perspective. So this is really important as we move to the new data model. Okay, now for the fun stuff, let's figure out how to build that chart. What we want to do is we want to compare actuals to targets. So let's make a new sheet. We're going to call it DNA chart. I learned this technique from Andy Kriebel. Thanks, Andy, for all that you do for the Tableau community. It's really appreciated. We've learned so much from you. Okay, so let's compare jobs after graduation as an end value to government targets. That didn't quite work. Let me try that one more time. So let's compare government targets to the number of jobs after graduation from our actuals. To do this the quick way, I'm going to double-click on Measure Values. I'm going to expand this list just so I can see it a little easier, and I'm going to filter based on measure names. I'm going to double-click on this, and I'm going to keep Will Job After Graduation and Government Target. Next, I want to drag measure names onto color instead of columns. So let's drag it down there. Now that we have this, we can find our geo field and double click on it. We'll then change our mark type to a circle. This is a pretty good start actually, but I got it kind of sideways to what I wanted. So let's click the rotate button, and now we actually have something pretty close. Note that because we generated random targets, this image won't match exactly the one that was in the PowerPoint presentation. That's okay for our purposes. To make this a dual axis chart, we need to duplicate the measure values. On a PC, you can hold down the control button. On a Mac, you can hold down the command button and drag the field literally to its right. We now have two axes. You can right click on one of them and say dual axis. Make sure to right click on the axis and tell them to synchronize. In this example, it's actually pretty close, but it's always safer to make sure they're synchronized or we may run into erroneous conclusions. Once we've done that, click on one of our axes and change it from a circle to a line, and then drag measure names from color onto path instead. You should now get something that looks like this. Inevitably, I tend to get this backwards, so if that also happened to you, you can right click and say move marks to the front. Now our circles are in front of our gray line rather than the other way around. This is the basic idea of how to create the DNA chart. Now, you'll notice that all of our provinces are under the government target. And the reason for that is that we actually had two different data sources for our targets that were effectively appended together in Tableau Prep. So if I drag this up there and just keep the targets that were generated by Python, we can now see a more reasonable distribution. So for example, we can see that Quebec is above target and Alberta is below. This gets us pretty close for our DNA chart. Last but not least, we want to see how this works when we aggregate and disaggregate our data. To do this, I'll show it as a crosstab. So I'll right click on my DNA chart and say duplicate as crosstab, and then I can see this here. So what we can see now is that our government target, the column on the left, is pretty reasonable as compared with the column on the right, which is our actuals. If we add additional detail, such as field of study, level of study, we can see now that field of study was a unique value, but level of study is not, because the government isn't targeting level of study in our fictitious example. But we can see that these targets are quite reasonable. If we add our subtotals and our column totals, just for sake of argument, we can now see that our totals are quite reasonable. What's different than the other older data model, where it was all physical, is that even if we add something like level of study, where the government has not targeted it, if we scroll down to find our Alberta totals, we can see that Tableau is still aware of what the correct total should be, so that our comparison is reasonable, even though we have this duplicate-looking entry because we don't have these targets based on specific levels of study. So this is really helpful when comparing targets to actuals because Tableau is range aware and it's smart enough to know how we're trying to do our comparison. It does its sum accordingly rather than adding all of the individual rows together. So this is really helpful as we move forward. As a set of rules of thumb, my own personal preference now is use relationships if at all possible. If they don't work, try using joins. If joins don't work, I could use data blends. Now, there's always cases where you might want to use blends or joins instead of relationships, of course. But my own experience is that relationships solve almost all of the issues that I had with formatting data for the purpose of using it in Tableau. It's much more efficient. So use the other ones sparingly, try relationships first. As mentioned, we'll have a webinar November 26th of 2020 focused on how to make this imaginary set of targets using Tableau Prep Builder. We're going to focus on how to write to a database, create the targets, and integrate with Python. You can register on our website or subscribe to our YouTube channel to get the update when the video of this webinar is posted. Thanks very much for watching.